Good morning. I just got a notice that says you're live. So, what I would like to do is we have our exercises 1 through 16 today, and I want to start at the back, and that would be with number 16. So right now, this exercise set (11 through 16) has to do with stating the domain and range of the function, then identify the new values or reference points in asymptote. Use these values to graph the function. So I'm going to go backwards from 16. So here we are at 16, and we're given this p of x equals 2 times 4 to the power of x minus 3 minus 5. The first thing I'm going to do is verbalize what's happening here. This 2 is A, and this is going to vertically stretch or compress. This value of h will shift left and right. And finally, this negative 5 is going to shift up. This value here, k, will shift up, down. So I'm going to say here f of x, or p of x, is f of x equals 4 to the power of x. This 2 will be stretched by a factor of 2. Will be this minus 3. What does that do? Well, it's going to be 3 units which way? To the right. So translated, three units to the right and this minus 5 is 5 units down. Translated, 5 units down. Okay, so now we have our reference points. Well, first thing, we have this negative 5. So what I'm going to do is go down to put down our horizontal asymptote. Y equals negative 5. So that's going to be our horizontal asymptote. And we're going to take the values, the reference points of, if we put in, to get our reference points, we're going to put in x, f of x. We're going to put in 0 and 1. Well, if we put in 0, to 4 to the x, we get 1. And if we put in 1, 4 to the 1 power is 4. So these are the points we need to transform. So we have 0, 1, and the first thing we're going to have is for a is equal to 2, which is our stretch. So what do we do when we multiply this by 2? We're going to get 0, 2. Okay, the next thing we're going to do is we're going to take this h value of -3, because h equals -3, so I'll put h is equal to 3. So what is that going to do? It's going to take this 0, 2 and move it 3 to the right. So we have 0 plus 3, or 3, 2. In the last transformation, we have k is equal to -5. And working to the right here, we have 3, the x value unchanged, and the y value is going to be 2 minus 5, and 2 minus 5 is -3. So this is going to be one of our transformed reference points. Now next, we're going to take the point 1, 4, and we're going to multiply this by a by 2, and working that out, we're going to take this 4, multiply it by 2, and get 8. Next, we have h is equal to 3. So we have 1 plus 3 is equal to 4. And then we have k is equal to -5. So that's going to be 4, 8 minus 5, which is 3. And so we have our two reference points we can plot. So the first one is 3, -3. I'm going to go to red. So 3, -3 will be this point here. And then we have 4, 3. So to the right 4 and up 3. So what is the graph of this thing going to look like? Something like this. Okay, so now it says state the domain and range. So our domain is going to be all real numbers, which it is for all exponential functions. And our range is going to be greater than -5. So we'll put -5, infinity. So we have our domain and range, our sketch graph, our transformed reference points. Everything is here. Chime in if you have any questions. I'm going to plan to go back to number 14. Yeah, and I didn't articulate this the same way over here. So we have 0, 1 becomes 3, negative 3. 1, 4 becomes 4, 3. Okay, horizontal asymptote is y equals negative 5. So really that's it. Okay, on to 14. Here we have a is equal to negative 3. We have this x plus 1. So this is going to be h is equal to negative 1. And we have this plus 3. So we have k is equal to 3. And really we can take our, I'm going to just put the k equals 3 first. So horizontal asymptote is y is equal to 3. All right, so that's one of our things. Now we're going to take our points here, and if we go ahead and put x, f of x, well, actually, well, that'd be different. It'll be the original f of x. If we put in 0, we'll get 1. If we took 2 to the power of x, and if we put in 1, we would get 2. So these end up being like our standard points that we're going to be transforming. So we start out with 0, 1, and then we're going to do a bunch of transformations. The first thing we're going to do is this negative sign reflects about x-axis. So I'm going to put reflect x-axis. So what that's going to do, that's going to take this 0, 1 and make it 0, negative 1. And now we have this stretch by 3, so stretch by 3. And what that's going to do is going to take this negative 1 and multiply it by 3. So we're going to get negative 3. The next thing we're going to do is h is equal to negative 1. So we're going to take this 0 minus 1 to get negative 1. So we're left with negative 1 comma negative 3. And the last thing we're going to have is k is equal to 3. So we're going to take this value of negative 3 and add 3 to it. k is it's equal to positive 3, right? Yeah, positive 3. So we got negative 1, and then we have negative 3 plus 3, which is 0. So we have 0, 1 becomes negative 1, 0. Okay, next, we're going to take the second reference point, 1, 2, and then we're going to reflect, will be the first thing we do. And I really suggest that when you do these transformations, it really helps to do them in this order. So we're going to take 1, 2 becomes 1, negative 2. And then we're going to stretch by a factor of 3 by 3. So we're going to take this 1 and negative 2 times 3 is going to be negative 6. Now we have h is equal to negative 1. So we're going to take this 1 minus 1 will be 0. So we have 0, negative 6. And then we're going to have k is equal to 3. So we're going to have 0, comma, and negative 6 plus 3 is negative 3. So our point 1, 2 becomes 0, negative 3. And then we can plot these points here. Negative 1, 0. There's negative 1, 0 right here. And then we have 0, negative 3. So what we have here is the graph looks like this. We'll come down here. Let me so we're going to hit this point here and this point here, and that's roughly what it looks like. I can move this over a little bit. Yeah, it looks a little more like this. So really that's it, other than our domain and range. So we got our horizontal asymptote, y equals 3, our reference points moving, and lastly our domain and range. So our domain is going to be what the domain for all of these is, which is negative infinity, comma infinity, and our range is going to be less than 3. So range is going to be negative infinity, comma 3. So that's our domain and range. Okay. Now continuing to go back to 12. Okay, for 12, again, we have k of x equals negative 0.5, 4 to the power of x minus 1 plus 2. So if we take k, f of x would be the original function. We'll say f of x equals 4 to the power of x. So for that, we're going to get x, f of x, 0, 1, and 1, 4. I think that's just like we started out in number 16. So these will be our starting reference points. And for this actual problem here, we're going to have a is equal to negative 0.5. We have x minus 1, so k is equal to 1. Or h is equal to 1. And k is equal to 2. So let me draw in that horizontal asymptote here. So our horizontal asymptote is the equation y equals 2. So I'll put it right here, y equals 2. Okay, now to do the translation or transformation, we have 0, 1, we're going to have, first of all, a reflection because we have our negative sign. I'll just put reflect. So this reflection is going to be 0, negative 1. Next we have a is equal to negative 0.5, and what that's going to do, we've already taken care of that negative sign. So we're going to have 0, negative 1 times 0.5 is going to be negative 1/2. So we got negative 1/2. Then we have h is equal to 2, h is equal to 1. So we're going to add to this 1. So we have 0 plus 1 is 1, negative 1/2. And finally, we have k is equal to 2. So we have negative 1/2 plus 2. That's going to be plus 1.5. So I'll just put 1.5. You can put 3 halves. So we have 0, 1. I'll just write an arrow here. Goes to 1, 1.25, 1.5. There we go. Okay, next we have 1, 4. And reflect. We have 1, negative 4. Next, for a is equal to, I'll just say compress, vertically compress. So we compress. that 1 will stay the same, but this negative 4 will be multiplied by 1/2, so we'll get negative 2. And then we're going to have h is equal to 1. So we have 1 plus 1 is 2. And then we bring over that negative 2. And finally we have k is equal to 2. So we're going to bring this 2, and negative 2 plus 2 is 0. So we end up having this 1, 4 translating over to become 0, 2, 0. 2, 0. And now to graph this, we have 1, 1.5, so there we go. And we have 2, 0. So what that's going to look like is this. Okay, so that's what it looks like. And last thing, domain and range. Domain, all real numbers. Range, we have negative infinity up to but not including 2. So negative infinity to 2. So it's going to be, our answer is going to be all this. Okay. That's it. Okay, next we're going to go to 10. And I'm trying to go from more difficult to easier by going backwards. Describe the graph of g of x equals 10 to the power of x plus 7 plus 6 in terms of f of x equals 10 to the x. So this is going to be h is equal to negative 7. Why is that? Because x minus negative 7 is x plus 7. And we have k is equal to 6. So f of x is translated 7 units to the left and 6 units up. That's it. Okay, 8. Now this is a different set here where you're graphing two different things. I'm going to make use of, I'm going to erase this bit of work here from problem 7. So what I'm going to do is put the table for the first one here, f of x equals, so you have x, f of x. So my recommendation is just to put some basic points to draw, to just sketch the graph of this. So if we have x equals -2, -1, 0, 1, 2, 10 to the power of 0 is 1, and 10 to the power of 1 is 10, and 10 to the power of 2 is 100. And then if we put in -1, we get 10 to the -1 power, which is 1/10, and 10 to the -2 power is 1/100th. So what we're doing for the graph of f of x is we have this, at -2 we have 100th, -1 we have 1/10, at 0 we have 1, and at 1 we have 10, and at 2 we have 100. So it's going to be a very steep looking thing here like this. That's what the graph of that's going to look like. And then for this second one here, let me get a skinnier pen here for this. We have x, g of x. So we're going to have the same input values, -2, -1, 0, 1, 2. And we're going to subtract 6 from all of these we originally wrote, because that's what this k value does. So instead of 0, 1, we have 1 minus 6, or -5. For 1/10, we're going to have 10 minus 6, or 4. For 100, we're going to have 100 minus 6, or 94. And then for -1, we're going to subtract 6, so it's going to be like 0.1 minus 6 is going to be equal to -5.9. So that's going to be -5.9. And then we're going to have 0.01 minus 6, which is going to be -5.99. Is that right? Yeah, -5.99. So all you're doing is taking this, just going to sketch over the original graph I drew. And I'm going to take this and cut it down, and just, there we have it, bring it down 6 units. 2, 4, 6. So it's going to look like this. Okay, so this is going to be this red one here is going to be g of x, and this blue one here is going to be f of x. Okay, so that's number 8. Now we go back to, now in the prior video what I did is I did number 6, so that really leaves number 5 undone. And what we're talking about here is just this 2 in front. That's a equals 2. So I'm going to just go ahead and put this down here. So we'll put x, f of x And it's to the 10th power, so it's the same as that last one we did for number 8. So we have negative 1, or negative 2, negative 1, 0, 1, 2. And then our output values are 1 100th, 1 10th, 1, 10, and 100. And with A being 2, what we're going to have is x, it'll be g of x. So all we do is we take same input values, negative 2, negative 1, 0, 1, 2, and then we're going to just multiply all these by 2. So we have 2 times 1 100th, which is going to be 1 50th. We have 2 times 1 10th. It's going to be 1. No. I got it wrong, don't I? You know what? No, that's right. 2 tenths is 1 5th. We have 1 times 2 is 2. 10 times 2 is 20. 2 times 100 times 2 is 200. Now this one here, to sketch f of x, we have this one here. Negative 2 is 1 100th. Negative 1 is 1 10th. 0 is 1. 1 is 10. 2 is 100. So it's going to look like this. And just go nearly straight up. This is what exponential graphs look like. And then for this other one, stretched by a factor of 2. It's really going to be hard to graph this to look accurately, but it'll look the same here. We have 1 5th. We have 2, so it looks a little different there. And then 1's going to be 20. So things are going to look just like this. It'll look very close initially, but then gradually kind of separate. It'll be just to the left of that blue curve is what it amounts to be. So this is kind of what it looks like here. So just steeper, and that's it. Okay, in 4, what you have is you have 2 to the x power and 2 to the x power plus 5. So 2 to the x, and I'm just going to finish up pretty quickly because I don't have very many concurrent viewers, and so we have x, f of x, and we have negative 2, negative 1, 0, 1, 2. So that's going to be 1 4th, 1 half, 1, 2, and 4. And then, so you're just going to look like this. Negative 2 is 1 4th. Negative 1 is 1 half. 0 is 1. 1. Yeah, I got that wrong. 1 half. 0 is 1. 1 is 2, and 2 is 4. And 3 is 8. So 3 would be 8. So you can look like this. And And then you have g of x is 2x plus 5. So you're going to just add 5 to each of these. And I'm not going to write out the table. I'm just going to shift it up here. So you take this one here. We just take this and shift it up 5 units. Two, 4, 5, yeah. So 0, 1 becomes 0, 6. So it'll look something like that. Okay, and then number 2, what you're doing is you're stretching by 5 and reflecting down. That's what you're doing on 2. So 2 to the x is going to be the same one we did before. We have negative 2 is 1/4. Let me get this here. Negative 2 is 1/4. Negative 1 is 1/2. 0 is 1. 1 is, 0 is 1. 1 is 2. 2 is 4. 3 is 8. So we're going to look like this. And then what you're going to do is take each of these input values, which are going to be our output values, and stretch them by multiplying by negative 5. So this 1/4 becomes negative 5/4. This 1/2 becomes negative 5/2. This 1 becomes negative 5, and so on. So what's going to look like is this. We got negative 5, negative 2 is negative 5/4. Negative 1 is negative 5/2, so that's going to be about down here. And 0 is going to be negative 5. So it's going to look something like this. So the thing is going to look like this. Down and really steep. A lot steeper. It's going to look something like this. So anyway, that's it. I'm going to have this saved for viewing. We're going to finish up chapter 13.2 next week. We have some real-world exponential growth problems. Thank you for those who have been there, and I will let you know what's going on tomorrow. Thanks.